Hey everyone, hope you're doing well. Today we're going to be looking at how to overlay text on top of images. So in a previous episode we looked at overlaying images on top of other images, but now we want to focus on doing the same thing but with text. And it's a similar process, but first we need some kind of way of getting information out of a font file. And to do that, I found this library by Thomas Altman, and it is exactly what we need. So basically it's going to allow us to read font files and get the image data for individual characters. So here's the documentation for that. I'd also like to point out that it is a C library. I have gone out of my way to transform it into a C++ library for you guys, so if you want to use this library, make sure you get the code from the GitHub in the description, not from here, because it won't work with C++ unless you make a lot of changes. Okay, so we're going to go ahead and just include this library here. We also want to create a struct called font that will forward declare, and then go down here and start creating that. So this is kind of our own little wrapper for the font from the library we're going to use. So it is called SFT. It's this structure right here, and we want to load in the font. But first, we're going to initialize it at null. The size will start out at 12, which I believe is the smallest you'll ever want to go. And then the X and Y can be 0. And then for flags, we want to set SFT downward Y, because on our screen, Y is down. And then we also want to set SFT render image, because we want to actually get the image data from the characters once we create them. So let's go ahead and add that as well. Okay, and then once we do that, we can make our constructor. We're just going to pass in the file name for the font. And please keep in mind this library supports TTF, true type font files. It will support some open type fonts, but mostly TTF. And we're going to use this load file function, which will return null if it fails. So we'll use an if statement to see if this function fails. And then we will just print out some kind of error message in case that the file does not get loaded correctly. Alright, and the next thing we want to do is set the font size, and we're actually going to have a separate function for setting the font size, because it would be nice if once you create the font you can change the size whenever you want without having to reload the whole file. So we'll have this set size function that will just set the X scale and the Y scale to the size that the user passes in. And then once we've done that, we finally have to actually set our sft.font to the information that we get from load file. Otherwise we're just going to be doing nothing with that information basically. And then finally in our deconstructor we need to free up the memory from that font, which is going to be done with this function right here. We just pass in the font, and that's about it. Don't forget that semicolon either. So now we can actually create our function for putting text on top of images, and we're going to call it overlay text. It's going to take in the text that we want to actually put on top of the image. It'll take in the font. We'll pass it as a const reference to avoid copying it. We will also pass in the X and Y position that we want that text to appear at, and then we're going to have R, G, B, and A so that we can set the color of that text using this function as well. So we got a whole lot of parameters here. I'm going to default R, G, B, and A to 255 so that we're starting out at white as our default color, but of course you can change that. We'll just print this into our C++ file and fix it up. Make sure we have our specifier there. And we got to get rid of all of these default arguments as well. Once we've done that, we're ready to get started on the meat of this operation, and that is reading in our characters. So the first thing we want to do is get the size of the string that we want to put on top of our image using string length. And we'll just save that in a variable because it's going to be pretty useful. And then we're going to loop over all of those characters individually and get information from them using our library. So to do that, we want to use the SFT char function. And if we look, it's going to give us this SFT character structure. So let's go ahead and start pasting this in and filling this out. This we're just going to pass in our font.sft, and of course we want a pointer to that. The char code is just the character. And then finally we need to make an SFT char structure that it will actually put the data into. So let's go ahead and do that. And now if we look, we can see that it will return 0 if everything went a-okay. Otherwise it will return either -1 or 1 depending on what the actual issue was. And we didn't really care what the issue was, we just want to see if it worked or if it didn't. So if it didn't work, we'll print out an error. And we'll just go ahead and skip to the next character in the string. So if everything went according to plan, we should now have this image pointer here, which I've actually changed to a uint8 type. But if we have that, that means we can start reading that image. It's important that we make sure to free the image after we're done using it, so we'll just put that at the bottom of the for loop. In addition, we also have this advance variable inside of the character, which tells us how far forward to move in the x direction. So we'll also add this in here, x plus equals c.advance, to make sure we're moving forward every time. So now we can start looping through the actual image that we get from SFT char. So to do that, we're going to create a nested for loop here for the y direction and the x direction. And if you remember, we have this c width and c height that we can use to do that. And what we're going to do now is we're going to create some variables. So let's start off by making dx and dy, which is short for destination x and destination y. This is where we want each pixel to show up on our image. And then we're also going to have a uint8 type pointer to hold that destination pixel address. And since the image is grayscale, or sorry, the character image that we get is grayscale, we don't need to use a pointer here. It's just going to be 1 byte. So we will just leave that as a uint8. Now we can go ahead and just calculate our destination coordinates. We're going to take the source y plus the offset y that we get as a parameter, plus the y for each character. Each character is going to have an x and a y, and it's very important that we include that because otherwise the text won't be aligned correctly. So we're going to do the same thing for dx here. And then if you remember from last episode, our overlay function, we have these if-else statements to check if the source that we're drawing onto the destination is out of range. So we're pretty much going to copy that exact same thing here. So if our y position is less than 0, we're just going to skip. Otherwise, if the y position is greater than the height, we can go ahead and break out of the loop. And then we can do the same exact thing for the x. Of course, we're going to be looking at dx, not dy. And we want to look at the width, not the height. Okay, so once we've done that, the next step is going to be actually getting our pixel data and storing it in destination pixel and source pixel. So to do that, we're going to take our destination coordinates and just index into our image data, just like we did before with the overlaying image. And then for the source pixel, this is just going to be c.image, and then we want our sx, sy pixel. Alright, now that we have both of the pixels, this is going to start looking a lot like the function we wrote in the image overlaying episode. So what we can do actually is we can copy this, because we want to do the exact same thing with alpha blending and all of that. Of course, there's going to be some modifications, but we are basically doing the exact same thing. So I'm just going to go ahead and copy this down to our other function and start making some modifications. So the first thing is, of course, that our source alpha, we do not have multiple channels here, so we can actually just get rid of this. What we want here is to use our source pixel to determine what the source alpha is, because as you remember, it's a grayscale image, and basically each value is going to represent the color intensity. But we also have this alpha parameter that we pass in that we have to consider as well in case we want the text to be slightly transparent. So we're going to multiply that by the alpha for the color that the user passed in and divide that by 255, and that is going to be our source alpha. So now this part's going to stay kind of similar, except we don't need to have that mem set anymore. We know that we're copying a one channel image to a image that has one or more, so we can go ahead and get away with mem copy, except we need to store the actual color that we want to copy in here. And to do that, I'm just going to set up an array that we're going to hold our RGB and A values in. That way we can just copy it all in at once, do it all in one line. And then we can just mem copy color into the destination. And that's about that, as long as both of those pixels, both source and destination, have no transparency, we can just do that mem copy. Otherwise, of course, we're going to have to do some kind of blending here. One thing we can also do is if our source pixel is 0, that means it's basically completely invisible. So we don't need to actually do anything. So I'm just going to wrap this whole chunk right here in an if statement. That way if the source pixel is 0, we don't have to do any unnecessary calculation. And that's just a nice little way to help speed up the calculation a little bit here. We don't have to do any of this floating point arithmetic if we don't want to. Okay, so the next step is going to be, of course, to fix this blending. And originally we have, we're loading into the destination channels, and that's all good, but we no longer have multiple channels for the source pixel here. So we're going to actually just replace this with color. That way we load our actual color value into here. And then everything else is going to pretty much remain the same. So now what we can do is we can actually create some test code. Just take a look at this. So we'll just overlay some text on top of our forest image here. But of course, first we have to load in a font, and I have a font here that I can load in. Set the font size to 100, and then we'll go ahead and enter some string along with the font. And then of course we need the position, and then finally the color, which I'm just going to do red. We can leave that A as the default 255. Now let's go ahead and actually run this code, compile it, see what we get. And as you can see, we have hello on top of our image here with nice alpha blending around the edges to make everything look super nice. So that's cool and all. Let's go ahead and mess around with this a little bit more. Let's add in some alpha here and make sure all of our alpha blending looks super nice. Let's also take out this logo image. We don't really need to waste time loading that in. Try this again. You can see now it's a little bit transparent. You can kind of see the trees behind it. Okay, so one important thing to note is that our coordinates that we pass in here do not really represent the top left corner. In fact, what it really represents is the baseline of the text. So if I set the x and y to 0, you can no longer see the text because it is off of the screen. So if I were to lower this a little bit in the y direction, you can now, you should be able to see the text if I lower it in the y direction. But you just have to keep this in mind when you're working with this function, that the y position really represents the position of the baseline of the text. That does not necessarily mean the bottom of the text, because some characters like G's will have ligatures, I guess, that kind of go below the baseline. But for the case of hello, everything is above the baseline. Alright, so that's how you're going to overlay text on top of images. And as you can see, there's a lot to mess around with here. A lot of cool stuff you can do. So I hope you guys enjoyed the video. Please check out the code on GitHub if you're really interested. And as always, thank you so much for watching.